NASA's James Webb Space Telescope, JWST, has recently captured the first true photograph of a mysterious interstellar object, Oumuamua. This strange object, which has traveled for over a century before being identified, has been a mystery to astronomers. Initially suspected to be a comet due to its unusual behavior, it was later discovered by Robert Warwick at the University of Hawaii. Oumuamua was initially identified as an asteroid, a small rocky object found in the asteroid belt between Mars and Jupiter. However, more observations revealed that it was departing from the Sun at an unusual rate, contradicting predictions. The lack of visible outgassing in Oumuamua's case confused scientists as the object accelerated in a way that contradicted predictions, forcing a dispute over its classification as an asteroid or comet. One of the most remarkable elements of Oumuamua was its consistent brightening and dimming every 7.3 hours, indicating that the object was tumbling and most likely spinning about its shorter axis. This velocity would imply that Oumuamua is a hard object with a more substantial and long-lasting composition than most comets, which are loose and brittle. Its dark red color, similar to that of moons in the outer solar system, showed that it had been exposed to cosmic radiation for millions of years, altering its surface composition. Suspects have speculated about the true nature of Oumuamua, with some hypothesizing it may be an advanced extraterrestrial probe or decommissioned alien spaceship, while others considered more feasible possibilities such as a previously unknown type of comet or asteroid. More conservative theories suggest that Oumuamua is the relic of an exoplanet that was ejected during a catastrophic event in another star system. Determining Oumuamua's future path has proven tricky as it has already begun to move away from the Sun, exiting our solar system at a sharp angle. Current estimates indicate that Oumuamua is returning to interstellar space, where it will continue its lonely track across the universe. Various theories have emerged to explain the origins and nature of Oumuamua, including the idea that it was ejected from a distant star during a supernova explosion and the idea that it originated when two celestial bodies collided and melted, resulting in a unique hybrid shape. The discovery of Oumuamua, a mysterious object, has led to various theories and discoveries about its origins and behavior. Astronomers have concluded that Oumuamua must have passed close to a new star system before joining our solar system, as its speed was similar to that of nearby stars. Another intriguing theory suggests that Oumuamua could be a piece of nitrogen ice, which could explain both the object's composition and unusual acceleration. One of the most important discoveries made shortly after discovering Oumuamua was that it was traveling in a hyperbolic orbit, a boomerang-shaped trajectory that strongly suggested it was not native to our solar system. This disclosure sparked speculation regarding its future visibility, with many believing that Oumuamua would vanish into space, never to be seen again. However, the object's behavior went against expectations, with an unexpected increase in speed as it approached the Sun. Gravitational forces from large celestial entities can accelerate smaller objects such as comets and asteroids, but Oumuamua's acceleration cannot be entirely explained by this. Several advanced theories were proposed to explain Oumuamua's acceleration, but each contains significant gaps or unresolved concerns. Jennifer Bergner, assistant professor of chemistry at the University of California, Berkeley, and Daryl Seligman, postdoctoral fellow at Cornell University, proposed a novel explanation: outgassing driven by processes occurring outside our solar system. They also discovered that Oumuamua was exposed to cosmic radiation, which might have triggered the release of stored hydrogen within the object's ice structure as it warmed up after entering the solar system. Decades of experimental investigation corroborate the duo's theory, which states that high-energy cosmic rays can break molecular hydrogen from water ice and store it within an item. However, not every scientist is convinced of this new notion, and some propose sending robotic probes fitted with satellites to intercept and investigate Oumuamua more closely. Due to its unusual behavior and unidentified sources, projects like Breakthrough Starshot are investigating the idea of spacecraft driven by sails capable of reaching far-off stars. Despite the early stages of technology advancements, catching up with Oumuamua remains out of our grasp. Its fleeting visit has provided insights for future visits with such objects. Although it may have taken billions of years to reach its present position, The passage of Oumuamua across our solar system marks only a fleeting moment on a cosmic scale, as it could have traveled across up to 20,000 distinct star systems over its long path. This indicates that Oumuamua has had many cosmic interactions, possibly gathering dust and debris from various environments along the way. Some researchers, including Elon Musk, have hypothesized that Oumuamua might be approaching the Kuiper Belt, a region of frozen planets beyond Neptune. Nobody has identified its precise location or verified its future course. The movement of Oumuamua has among its most perplexing features unusual acceleration, which revealed other factors at work. Celestial bodies are usually driven mostly by gravitational forces. Astronomer Dr. Michelle Bannister put forward several possible reasons for this unusual acceleration, including outgassing, which is a behavior typical of comets. However, thorough searches turned up no gas emissions, suggesting that Oumuamua could be chemically unique from any comet known in our solar system. Scientists battled to find the usual signs of outgassing, such as cyanogen, CN, gas often found in comets, but thorough searches turned up no gas emissions. This suggests that Oumuamua could be chemically unique from any comet known in our solar system. Researchers even tracked it for more than 30 hours using the Spitzer Space Telescope, but their efforts produced no clear answers. The lack of thermal emissions and obvious gas made the classification of Oumuamua much more difficult. In the 6 months before the near encounters of Oumuamua with Earth, a tiny interstellar meteor of 3.1 meters in size was discovered on our planet. Harvard scientist Avi Loeb became interested in this meteor, called IM-1, and Sean Kirkpatrick, director of the Pentagon's All-Domain Anomaly Resolution Office, AARO, addressed the government's chosen term for UFOs, Unidentified Anomalous Phenomena, UAP. Loeb's hypotheses center on the possibility that extraterrestrial civilizations would be interested in researching rocky worlds with atmospheres such as Earth, Mars, and Venus. He likens this concept to looking through a mailbox for letters from someone who might no longer be alive, suggesting that probes could carry on their mission even if the civilization that produced them is long gone. Loeb has encountered great mistrust from the scientific community after suggesting that Oumuamua could be an alien spacecraft in 2018. Many researchers contend that his idea is theoretical and devoid of strong data. Researchers have backed the natural explanation by pointing to hydrogen outgassing as the most likely cause of Oumuamua's unusual acceleration. On March 22, 2023, results pointed to this process, implying that as Oumuamua passed through the inner solar system, it most likely released hydrogen held inside its frozen body, simulating propulsion from an unidentified source. The Pentagon has stepped up its probe of inexplicable aviation events within American territory, with over 360 fresh investigations into alleged contacts with unidentified objects involving U.S. military personnel since its founding. About half of these events have been linked to balloons or other items, while the other half remain unsolved due to inadequate evidence. In this text, the author discusses the mysteries of interstellar space and the potential for spacecraft to explore it. The author argues that humanity must have a better understanding of dark energy and cosmic phenomena to send a spacecraft after an object like Oumuamua, which is moving at incredible speeds. This expedition presents major obstacles, such as the need for advanced technologies like solar sails or speculative propulsion techniques like wormholes. The author also acknowledges that humans are unique among Earth species in their desire to explore space, as most animals on Earth have no regard for what lies beyond their immediate surroundings. This raises questions about potential extraterrestrial civilizations, as most creatures on Earth are oblivious to the larger cosmos. The author also discusses the development of the Fermi paradox, which underlines the conflict between a high possibility of extraterrestrial civilization existence and our complete lack of proof for them. With over 400 billion stars in our galaxy, many of which are expected to have livable planets, it is reasonable to expect intelligent life to originate elsewhere and develop interstellar travel technologies. However, there has been no strong evidence of their existence, leading some to suggest that our search efforts are fruitless and that resources should be redirected elsewhere. The author also discusses the dark forest theory, which proposes that advanced civilizations may remain silent out of fear to prevent detection or due to a lack of interest in exploring the universe. This idea holds that the universe is similar to a dark forest, with each civilization acting as a silent hunter, avoiding notice to ensure survival. The dark forest theory also posits that alien life would think similarly to humans, focusing on self-preservation and competitiveness, but this assumption could be erroneous. In conclusion, the author emphasizes the importance of understanding the mysteries of interstellar space and the potential for spacecraft to explore it. They also acknowledge the challenges of finding an acceptable solution to the Fermi paradox and the need for continued funding for research into extraterrestrial intelligence. The concept of extraterrestrial civilizations is a complex one, with the idea that if other civilizations were less technologically advanced, they might not be able to send messages or build spaceships. This suggests that our current search methods may produce false negatives, as we are looking for indicators of civilizations that do not yet exist or have only recently developed essential capabilities. In 2019, an amateur astronomer at the Margot Observatory in Crimea discovered a new comet called 2I/Borisov, traveling through space at an amazing speed of 93,000 kilometers per second. This discovery immediately piqued the interest of experts worldwide, as it was significantly faster than what is normally reported for objects in our solar system. Researchers were intrigued by the comet's speed and its odd course, which showed that it came from outside our solar system, making it the second confirmed interstellar object ever discovered. 2I/Borisov was easily identified as a comet, having the usual characteristics of a comet, including a visible tail. It came closest to Earth on December 28, 2019, at a distance of about 2 astronomical units, AU, and brightened before progressively disappearing from amateur astronomers' view by October 2020. Dr. Michel Bannister's team conducted extensive observations on 2I/Borisov, calculating its diameter to be between 1.2 and 10 million kilometers, 2 to 16 kilometers. They also identified the emission of cyanogen, CN, gas from the comet's surface, which is a frequent feature of comets but proved difficult to detect due to the comet's faintness. The enhanced visibility of 2I/Borisov made it especially useful for studying its composition and behavior, providing a rare opportunity for scientists to investigate the chemistry of an object that originated outside of our solar system. Two distinguishing features of 2I/Borisov were its comet-like appearance and its reddish hue, which is consistent with many comets seen in our solar system. Two of the most fascinating events in the cosmos are black holes, which are believed to develop when large stars collapse under their gravity. Millions of black holes are thought to be strewn about the cosmos, with approximately 100 million possibly existing. Recently, a team of scientists reported the finding of a black hole named Gaia BH1, which is 3 times closer to Earth than any other black hole yet found and around 10 times the mass of our Sun. The Gaia spacecraft has shown great validity, giving this discovery significant credibility. Gaia BH1 is particularly fascinating because of its proximity and modest size, making it a great candidate for further investigation. The study of interstellar objects such as Oumuamua and 2I/Borisov represents a pivotal moment in our understanding of cosmic phenomena. Beyond their immediate intrigue, these objects offer valuable insights into the processes and materials present in other star systems. As astronomers delve deeper into their origins and behaviors, they uncover clues that could reshape our comprehension of celestial dynamics and the formation of such bodies. The discovery of Oumuamua was groundbreaking not just for its unusual characteristics but also because it prompted a reevaluation of how we detect and classify interstellar visitors. For decades, our knowledge of interstellar objects was limited, and Oumuamua's unexpected trajectory and features demonstrated that our observational tools and theoretical models might need updating. The fact that it was detected only after it had already passed through the solar system highlights the limitations of current astronomical surveys and the need for more proactive and extensive monitoring systems. Similarly, 2I/Borisov's discovery provided a rare opportunity to study a comet from outside our solar system in greater detail. Comets are remnants from the early solar system, containing primordial materials that can offer clues about the conditions and processes prevalent in the early stages of planetary formation. By analyzing 2I/Borisov, scientists could compare its composition to that of comets originating within our solar system, offering a broader perspective on the diversity of such objects across different stellar environments. Recent advancements in technology have significantly contributed to the study of these interstellar visitors. Telescopes and space observatories, such as the James Webb Space Telescope, have enhanced our ability to capture detailed images and spectra of distant objects. These instruments provide data that are crucial for understanding the physical and chemical properties of interstellar objects. Furthermore, the development of new observational techniques and analytical methods allows scientists to refine their models and hypotheses about these enigmatic travelers. The interest in interstellar objects extends beyond academia, touching on the potential for future space missions. The concept of sending spacecraft to intercept or study such objects directly is an exciting prospect. Missions could be designed to capture samples or gather more detailed information, potentially revealing more about the interstellar medium and the building blocks of planets and stars. Proposals for such missions often involve advanced propulsion technologies, such as solar sails or ion drives, which could enable spacecraft to travel at higher speeds and reach distant targets within a reasonable timeframe. In addition to technological advancements, the study of interstellar objects raises philosophical and existential questions about our place in the universe. The detection of extraterrestrial materials and the possibility of advanced civilizations spark discussions about the potential for life beyond Earth. If interstellar objects carry evidence of alien technologies or biosignatures, it could fundamentally alter our understanding of life's distribution in the galaxy. This possibility has fueled both scientific inquiry and speculative discussions about the nature of extraterrestrial intelligence and the search for signs of life beyond our solar system. As research into interstellar objects progresses, the collaboration between international space agencies, research institutions, and private enterprises will become increasingly important. Collaborative efforts can pool resources, share data, and accelerate the development of new technologies and mission concepts. The ongoing exploration of these cosmic wanderers not only enhances our knowledge of the universe, but also inspires future generations of scientists and engineers to push the boundaries of what is possible. Looking ahead, the study of interstellar objects promises to be a rich field of exploration with the potential for groundbreaking discoveries. By continuing to develop advanced observational tools, refine theoretical models, and pursue ambitious space missions, scientists aim to unlock the secrets of these enigmatic visitors. As our understanding deepens, we may find new insights into the origins of our solar system, the nature of cosmic phenomena, and the broader context of our existence in the universe.